what is the unit of first order rate constant? First order reaction rate constant. What is the unit of nth order reaction rate constant? What is the unit of rate constant of the second order reaction? This type of questions are very important question. We discuss about the answers of this question, that how can we find out the units of different order reactions rate constant. Different order reactions rate constant, for the rate constant of different order reactions, what are the units? We discuss about this topic, and to understand this topic fully, watch this video lecture up to the end. Hello everybody, I am Atanu Betal. You are welcome to this channel, and if you are coming first time for this in this channel, then you can subscribe it right now. Let's start our discussions regarding this topic. The topic you already know, that we are discussing about the units of rate constant of different order reactions. So first of all, we see the for zero order reaction. For zero order reaction, suppose a reaction A2 product, and in this reaction rate equation is like rate equal to K into A to the power 0. A to the power 0, this equation is the rate equation for zero order reaction. Okay, for zero order reaction the rate equation is rate equal to K A to the power 0, because A is the reactant molar concentration to the power 0. So in this case, the unit of the rate constant means K, rate constant of the zero order reaction. Rate constant means here K. So what is the unit of K? That is the question. So in this time we have to derive the unit of K from the writing unit of rate and unit of this one. Actually here A to the power 0 means 1, so here rate is becoming equal to rate constant K, because this one A to the power 0 equal to 1, A to the power 0 equal to 1, so rate equal to K. So in this case the unit of K equal to unit of the rate of the reaction, and you know that rate of the reactions, rate equal to what? Rate equal to change of concentration by time, change of time. So rate of reaction equal to rate of change of concentration with respect to time. That may be with respect to reactant or product. The rate of change of concentration of reactant or product with respect to time, that is defined the rate of reaction. So rate, in the rate of reaction, concentration, if we defined it as mole per liter and time in second unit, that time the unit for the rate of reaction is mole liter inverse and second inverse. Mole liter inverse and second inverse is the unit of the rate of reaction. So for zero order rate constant, you know the unit of rate constant K equal to rate of the reaction, and rate of the reaction, unit of rate of the reaction is mole liter inverse and second inverse, mole per liter per second. So we can understand that what is the unit of zero order rate constant. For zero order rate constant, zero order reaction rate constant, the unit of K, I am defining it K0 as for zero order, I am defining 0 by zero order rate constant K. The unit is mole liter inverse and second inverse, because here look at this equation, this is the rate constant rate equation for zero order reaction. Here a to the power 0 means 1 and rate equal to becoming only k. So unit of k is equal to unit of rate of the reaction, and rate of the reaction unit is concentration change by time change. So it is mole, liter inverse and second inverse. So the unit for the zero order reaction rate constant K is mole, liter inverse and second inverse. But if the reaction is taking place in gaseous medium, that time here the rate of the reaction, equation of the rate of the reaction is changes to the pressure by time, because at that time the partial pressure is coming in the expression. So that time pressure means, if we express the unit of pressure as atm, atmosphere second, so that time the unit is atm second inverse. Okay, that time the unit should be atm second inverse for the gaseous medium reaction. So this one, the equation, okay, we separately write two equations. For zero order reaction, rate equation, rate equal to k into partial pressure of a, partial pressure of a, this is for gaseous. For gaseous reaction, the equation is rate equal to k into partial pressure of a. This is for gaseous medium reaction. The rate equation for zero order reaction is rate equal to k into partial pressure of a. So, and partial pressure of a to the power 0. Okay, here partial pressure of a and to the power 0, because they here power is should be 0. So in this case this one should be equal to 1 and rate equal to only k, but the rate, for the unit of rate here pressure by time is taken, because it is the gaseous reaction. So therefore pressure and time taken, unit of pressure is atm and unit of time is second, so atm second inverse. So zero order rate constant k, it has two units. In the gaseous reaction it has the unit of atm second inverse, atm second inverse, and in the liquid medium the unit is mole per liter per second, that is in the liquid medium unit, and this is in the gaseous medium reaction unit. So the point is clear that how to find out the units of the zero order rate constants. Zero order rate constant in the gaseous reaction or in liquid reactions, whatever the types of reactions is, you can easily find the unit of the rate constant by applying this process. Now after discussing this zero order reaction rate constant unit, we should discuss about the first order reaction rate constant unit. You know, when a reaction is taking place in a first order, that time a is changing into products, and in this case the rate equation should be rate equal to rate constant k into a to the power 1. Okay, the equation should be like this, a to the power 1, and the order of reaction means this one, so this one is 1, so therefore the reaction is a first order reaction. So for this first order reaction, the rate constant k, we have to find out the unit of rate constant k, and we know that unit of rate equal to mole, liter per second. This is the unit for the rate of reaction, means this one, mole liter inverse second inverse, and K, and this one A, the concentration of the A, if it is taken the molar concentration of A, mole per liter. Mole per liter is the concentration of the A. So therefore its molar concentration, mole per liter, and from this we can find the unit of K, the first order rate constant K, first order reaction rate constant K. Look at this, both sides of this equation. From the both sides of these equations, mole per liter and mole per liter cancelled out, and now we can say K equal to second inverse only. So unit of the first order rate constant should be second inverse or time inverse. Okay, this is the unit of the first order reaction rate constant, second inverse AC. You can also write it ACC inverse, or totally you can spell it as second inverse, that is also true. So when the reaction is taking place in liquid medium, that time unit of the first order rate constant is second inverse. But the question is when the reaction is taking place in the gaseous medium. In the gaseous medium, when the reaction is taking place, that time this one is changing into partial pressure of A and to the power 1, because it is a first order reaction. So in this case, you know that in the case of gaseous medium reaction, it is becoming ATM second inverse, rate equal to ATM per second, atmosphere per second, K, and it is the partial pressure of A, that is ATM. So from the both side of these equations, ATM is cancelling out and the unit of K is becoming second inverse again. This is for the first order rate constant, first order reaction rate constant. The unit is second inverse. Okay, I think you understand this topic. Have any questions? I think you don't have any questions. You understand it clearly. Similarly, you can find out the unit for the second order reaction rate constant, for the nth order reaction rate constant, for any order of reaction rate constant. Now we see about the nth order reaction rate constant. For nth order reaction, what happens? Rate equation should be like K into concentration term to the power nth, means n. We don't know the value of n, when n should be 1, 2, half, etc. So for nth order reaction, the rate equation should be like this: rate equal to K into concentration term, molar concentration term, and to the power n. So in this case, the unit of K means rate constant, that should be mole liter inverse second inverse equal to mole liter inverse mole per liter to the power n. Okay, so right now the K is becoming as mole liter inverse second inverse divided by mole liter inverse to the power n. Okay, this is the unit of the nth order reaction rate constant. For the nth order reaction rate constant, K equal to mole per liter per second divided by mole per liter to the power n. Okay, so right now what we can do, we can do it as like mole liter inverse to the power 1 minus n and second inverse, because here you take it as 1, so mole liter inverse to the power 1 and n, so mole liter inverse to the power 1 minus n into second inverse. Second inverse, this is the unit for the general or nth order reaction rate constant K. You can write the unit as like K equal to mole per liter to the power 1 minus n and second to the power minus 1. In this way you can find the unit of any kind of rate constant, first order, second order rate constant unit from this general expression. Suppose we want to know the unit of the second order reaction. Second order, for second order you have to put n equal to 2. Okay, for second order reaction you have to put n equal to 2. So that time what is the unit of K? If we put n equal to, here n is present, n equal to 2, that time the unit is becoming mole liter inverse to the power minus 1, because 1 minus 2 means minus 1 and second to the power minus 1. So for the second order reaction the unit of rate constant is mole liter inverse, and second inverse. You can also write it as mole inverse, liter and second inverse. Okay, mole inverse, liter and second inverse, this is the unit of the second order rate constant. You can find this unit from this general expression of the nth order reaction, general expression to find out the unit of rate constant for nth order reaction. Similarly you can derive this unit for the gaseous medium reactions. For the gaseous medium reactions, what happens? For gaseous medium reaction, K equal to, rate equal to K into partial pressure of something to the power nth. Okay, in this case the reaction is becoming the nth order reactions, and for this case rate equal to here ATM second inverse K, partial pressure of A means ATM and to the power n. So the unit of the nth order gaseous reaction for K, unit for the rate constant K is equal to here ATM second inverse divided by ATM to the power n. So ATM to the power 1 minus n second inverse. ATM to the power 1 minus n second inverse, this is the unit for the general order reaction or nth order reaction in gaseous medium, ATM to the power 1 minus n second inverse. Okay, so I think you understand this total discussion, that how to find out the unit of first order, second order, nth order reaction in gaseous reaction or liquid medium reactions, means where molar concentration term is involved. You can easily find out the unit of different kind of rate constant for first order rate constant, second order rate constant by this process. So that's the discussions. Thank you for watching these discussions. If you find this video lecture is useful, then like it and subscribe this channel also.